Does anybody have any questions over homework or anything?
I know I heard those two working on it.
Number 25 was one that kind of started when we had the logs within the exponent.
What section are you working on?
6.5.
6.5, okay. You want me to look at number 25?
Yeah.
Okay.
The thing that confused me is the fact that the logs are the actual exponents themselves.
Oh, I see. Okay. So you have 3 raised to the log base 3 of 5 minus log base 3 of 4. Is this correct? Is this the one you want me to do? Okay. That just looks ugly. I didn't give you anything exactly like that, so that may have caused some issues. Any ideas? It's not an equation, right? So I'm not trying to solve an equation here. This just says use properties of logs and exponents to find the exact value. That's right.
Can we combine them or
Combine.
the two logs?
Sure. There's subtraction between them. You can. You want to do that?
Yeah.
So that's going to become 3, and then you'll have a single log now, right?
Yeah.
Log, and subtraction becomes division.
Division, so 5 over 4.
5 over 4. Okay, I like that. And then?
And then you can take that 3 and put that in the exponent or no?
3.
The big 3, yeah.
Yeah, that's what I did too, but apparently.
Oh, no. This 3 is not a number being multiplied out front.
Oh.
It's 3 raised to this.
Oh, okay.
Can you bring it to the front?
I put it in, I did a log one, put it in logarithm form,
Oh, so you rewrote this as a log now?
and then it's log base 3 of log equals log base 3 of 5 over 4
Yeah, so in log form, this would be log base 3 of...
x.
We're not trying to find x, we're just trying to find the exact value.
Yeah, see, you don't have an equation, but you can still convert to log form, but you would have to create an equation out of it to do that. I'm not saying that it's wrong. You could do it, but you would have had to have started by calling the other side something. Do you call it x or something? Okay. I like that. I mean, you could do that. But look, we had this property. This property keeps on peeking its head out, and I don't think y'all are seeing it. What is this?
Oh, it's x.
It's just x, right? Yeah. So if this is the same as this, you're taking 3 to the log function base 3. These are inverse functions, aren't they? This is the exponential function, and you're plugging in the log function into it, same base. This just drops the 5/4 out. That's your answer. See that? The 5/4 was this piece.
Because the both of the logs cancel because they're the same base.
That's right.
Right.
Okay.
So if there's a 4 that's the base, so that would be the simplest form.
Wait, if there was a what?
If there was a 4, if it didn't match, would that be it?
If this didn't match, then we couldn't go further with that. Any others?
Yeah.
So let's make it official. Your next exam, which is exam 3, is going to be next Thursday, which is
A week from today.
4/14, 16.
That would be correctamundo.
Yes.
Sorry, I'm a little bit busy. Got to do my.
Don't
tax.
remind me. Yeah.
It's okay. I already got mine and got the tax.
And like, what's good, is 6.6 going to be a part of that, or chapter 6.6? Is that going to be a part of the exam 3, or?
Yes, because we're going to do 6.6 today. That'll probably be where we stop. 6.6. I'm not sure how much review, but we will do some review.
I like that review thing that you gave out, like the practice
Mhm.
test to kind of.
Yeah.
Yeah.
Oh, I know you like those.
Well, it's not necessarily because of you, but it's kind of like, it's practice problem.
This average, like this test kind of like the average went down. So can you actually?
Yeah, this was the lowest average. We'll do something.
No.
We will do something.
Let's do.
We'll do
Let's do all.
some.
No, because this section is like pretty difficult.
Yeah. Make sure you're doing your homework.
I am.
Yeah.
But why are you trying to screw this like that? Like,
What do you mean?
why some? Why not do?
Because I don't want to do a whole day for it.
I know.
I don't mind spending like, 40 minutes on it or so. Yeah.
I thought you meant like.
No, not like 3 minutes at the
where
end.
it was like
No.
we went through last time.
We'll spend some time, but not a whole class.
So we're not doing 6.8
On the test, it won't be on the test. Okay. There was one topic from 6.5? No. Yep. No, 6.4 that I didn't cover in detail, and nobody asked me any questions about it. 6.4. So I want to make sure that we're clear on it now.
Is that exponentials?
Nope.
That was moderate?
Yeah, this was log function. Domains of log functions.
Oh, that came up in this one too.
Yeah, so I want to be clear here, make sure that we've got this base covered. And then we'll get back to where we left off last time. Also, a little off topic. You mentioned that proof to me about the mathematician, right? The other day you were talking about, did I hear about that?
Yeah.
And I was kind of like, no, I don't think I remember me saying, looking kind of confused. That's because proof of a theorem called Fermat's last theorem. And this guy got some national, worldwide recognition recently. They gave him a $700,000 award for it. The reason why I was kind of confused is because that proof, he did that proof in the mid or late 90s. He's just now getting recognition for it. He's getting money for it. So when you said that, I was like, Fermat's last theorem, that proof is known. So I thought maybe it was a new proof. Sometimes when proofs are done in math, someone will come along and do a better, more elegant, shorter, cleaner, easier proof, and they'll get like recognition for it. But it's the same guy, same proof, just now they're like actually giving him an award for it. That's why you're hearing about it. Like math people, we already knew that that proof was done.
Oh, okay.
So that's why I looked confused when you were like, it's like Fermat, it's, I recognize the name Wiles, yeah.
Yeah, so that's a lot of money.
I'm glad they know what
That
you're
must be
talking
pretty impressive.
Yeah, there's actually 7 problems. This international institution called the Clay Institution, I believe, put out 7 problems at the turn of the century. Back in like 2000, they put out 7 unsolved math problems, and one of them I think is a computer science problem, and they're $1 million each. If you can solve it, you get $1 million. This problem was not on that, but he was awarded $700,000 from some other group. He was given like the Nobel Prize basically for math. Anyways, so if you want to make a quick $1 million, just go solve one of these. There's actually only 6 of them. One of them got solved.
He's like, I did them last week.
No, these are not easy problems. I thought this was interesting. One of them was solved by this guy, and he declined the money.
Why?
He declined the money.
Did he already have $1 million? Or?
He's a mathematician. He didn't have any money. Yeah, just take-home problems.
He did the math. He's like, I'm going to have to pay this much tax.
Jump out of college. Literally.
He's like, no, I'm
Keep the bragging rights. I mean,
And then that cardboard box.
Oh, he's keeping the bragging rights. He's just not claiming the money, which I think is even more respectable.
That's very noble.
But, huh?
That was very noble.
Mm-hmm.
What is he like?
I'll be like, hell no, I'm thinking that money.
The reward for him was solving the problem. Okay, here we go. So we're going to take a step back a little bit just to make sure we're clear on domains. If you have functions, remember when you graph them, sometimes there's values of x you can't plug in, you can plug in, right? So for log functions, if you go back and you look at when we first defined logs, the graph of a log looked like this, right? This was for log base a of x. And what we said was that x had to be bigger than 0, right? you could not plug a negative number or 0 into a log. It had this asymptote. Does that look familiar? A little bit? So when we come over here and we start making these log functions a little more complicated and we start changing what's in here, then that changes what the domain is. The key to the problem over here is that the thing inside, right, the argument of the function, that's what we call it, the argument of the function must be positive. So when we look at this and we were saying, hey, what's the domain? The argument of the function is this, right? That must be greater than 0. So we just write that down. And then solve that linear inequality. Just add 5 to both sides. X must be greater than 5. And on a number line, that's 5, and that's everything over here, right? Yeah. But not 5. So as an interval, it would be, what would the domain be? 5 to infinity. There's your domain. That would be it. Understand? That's a very clean, simple one, right? Let's look at another one. What about f of x is natural log of the square root of 2x plus 5? Okay.
It has to be greater than 1.
So the square root of 2x plus 5 has to be greater than 0.
Yeah, so all of this is the argument, right? Everything in there must be. So the square root of 2x plus 5 must be greater than 0. Yeah?
So then we just square both sides.
Kind of, yes.
Treat it like an equation, right?
Yeah, okay, yes. If you want to treat it like an equation, you can do that. But make sure you turn it into an equation first.
Okay.
So you'd have to do this first.
I was just
So
making sure that we could do that.
you can, but you're going to have to test your answers. Do you remember quadratic inequalities? Yeah, that same sort of story here. If it's a linear equation, you're allowed to move things around and multiply. That's fine. But if you start doing things like squaring both sides, things like that, I don't know why I'm falling.
Plus or minus because you did it yourself. So
That sort of thing, yeah. Okay, so go ahead and square both sides, and then you get what, 2x plus 5 is equal to 0, so x is equal to negative 5 halves. Moving things around. Okay, that's what's going to make it 0. You don't want that, do you? You want it bigger than 0. So this is where you could go and use a number line.
but it's got to be plus or minus because we did the square. So you have to have test.
No. We never took square root. We never took square root. That's when you do plus or minus.
Oh, okay.
If you square both sides, you don't have to do that.
Okay.
But I do have to check on each side of this to see which side works. So test some points. So someone give me a point over here.
1.
1? 9? I heard 1. How about over here? Negative 5. Negative 5. There you go. Where are you going to plug those in? Right here, right? And in fact, you could go into this, but I can just check it here. Let's plug in 1. What happens when I plug in 1?
That'd be 2 plus 7.
Root 7? Yes? Good? That's bigger than 0? We're good. So this works, right? And that means everything over here works. Negative 5, plug in negative 5.
That'd be negative
negative root. You're not going to be able to do the negative root, right?
No,
A root of a negative number.
Yeah, no.
So that's not going to work. So your answer for this one is going to be negative 5 halves
To infinity.
to infinity.
And beyond.
And beyond, yes. Okay, let's try something slightly different than that one. How about f of x is just log x square root? That's different than this, right?
Whoa.
By the way, what's the base of that log? 10?
10.
Base 10?
We have this.
Yeah, that doesn't have any impact on what we're doing here, right? But
That looks like something you would give us on a test.
why?
Because you're crafty like that.
It's well, maybe, but that's right out of the book too. So I'm not going too crazy here. Let's look at this first. Let's talk about that.
Now my crafty, statement
Is X just the argument, or is it the whole thing under the?
Yes, I'm.
Okay, that's a good question. You actually have composition of functions here. Remember when we did like f of g of h of k of, we could do this function inside of a function inside of a function. You actually have a log function sitting inside of a root function. So you have to consider two different types of domains here. First, what's the domain of the log? Once we get that answer, we need to make sure that that answer is never what?
Zero.
Or negative.
This whole thing under the root can't be negative.
Well, we can't.
It can be 0 though, right? So let's look at the red part first. What can you tell me about x? X must be,
Equal to or greater than 0.
can it be equal to 0?
Yes.
Yes.
You sure?
Yes. No.
Yes.
What's
Because
log of
square root
0?
0 is 0.
What's log of 0?
1.
Uh-oh.
No, anything to do with power. Okay, so this has to be greater than.
What's log of 0?
The log of 1 is 0. Oh, you can't have that.
That's what log of 0, that one up there, that's what log of 0 is, right? 10 to what power is 0? Not going to happen.
So it's going to be greater than 0.
Greater than 0. You cannot plug negatives into logs, but you can't plug 0 into logs either. Now, log of 1 is 0.
Right, I agree.
So you got it switched, okay. All right, so far, do you agree that's the domain? Yes? X has to be greater than 0. But we also have this other condition that we need to make sure holds up, and that is that the log of x must be greater than or equal to 0, or else I won't be able to take the square root of it. Do y'all see that? This part deals with what I can and can't plug into the log, but then this is dealing with the fact that once I do it, what comes out has to be square rooted, so it has to be 0 or bigger. Okay? So look at that over there. How in the world do you think you're going to solve that? It's a logarithmic inequality. What does your gut tell you? Treat it like an equation first. Right? What's x? 1.
Because it's 10 to the 0th power.
That's right. You could do this using that little loop thing that I showed you all a while back, right?
I was just thinking about that, like I was doing that in my head.
Yep, good. So if you want to know what x is, this should be 10, base 10, right? 10 raised to the 0 should be x. 10 to the 0 should be x. So what's x? 1. So to make this equation true, right? This equation true, x needs to be 1. With me? Now I'm going to come over here, put a number line. Here's 1. Pick something over here, pick something over here. Okay, I'm not going to pick -1. Why?
Because it can't be negative.
Because I want to stick in this, I want to stick to what I already know. X must be bigger than 0. You could do a half. And then over here, 2, sure. And where am I going to put those? In here, right? Into this? Into this? Yeah? So I'm having second thoughts. Here's why I'm having second thoughts. This is log base 10, right? And I've got to plug that in here. Like I'm trying to plug 1/2 in here.
Right.
That might be hard for me to do unless I break out my calculator and use change of base formula.
Why don't you do like x is like 10?
1/10. How about that? And then over here, how about we use 10? That seemed like a kind of a more clever choice. Okay, so let's try 1/10. What's log base 10 of 1/10? So 10 to what power is 1/10?
That's negative.
-1. Isn't it? -1? Is -1 greater than 0?
No.
No, that doesn't work. Now plug in 10. What's log base 10 of 10? That's 1. Is 1 greater than 0? Yes, so that does work. You see how this works? And what if it was 1? What if x was 1? We get 0. And that's okay to have 0, isn't it?
Yeah.
So what is our final answer? We kind of have to combine the two ideas together here.
It's gonna be log
This one says x must be what? Bigger than 0. So I must be over here, first of all. And then this one says I must be what? Greater than or equal to 1? So here, and so what I'm looking at is where they overlap, which would be 1 to infinity. Including 1? With bracket. 1 to infinity. That's the answer. See, that problem is a little more complex than the one before. It's a very subtle change because the last problem the root was here. This one the root's on the outside, and it changes a lot of what you have to do in terms of analyzing it. Let's do another one. How about find the domain f of x equals log base 7 of x plus 1 over x minus 3. Oh, into 2 logs?
Yeah.
Can you?
Yeah.
How?
Well, it's just going to be log a7x plus 1, and then minus log a7x minus 3.
That's a really, really good question. Let me just put this with a question mark for right now, okay? No. I told you last class you could do that, right? Division in 1 log turns into this, right? What do we know? Obviously, you cannot plug in here.
0.
You can't plug 0, you can't, 3. 3 can't be plugged in here. This is undefined, right?
Oh, yeah, that's what I meant. The
Right.
base can't be 0.
So you cannot have this be 0. So we know x can't be 3 to start. If I plug 3 in here, I'm okay. If I plug 3 in here, 0. Log of 0,
Nothing.
undefined, right? Log of 0, we just said undefined a minute ago. Log of 1 is 0, but log of 0 does not exist. So I just want to make sure if we're going to peel this apart like this, we need to make sure we don't lose that domain restriction. X can't be 3 here, but still x can't be 3 here. Understand that?
That logic, x also can't equal -1 because if you put it up top, that means it's 0 as well.
That's right. That's right. And we're going to get that right here. We're going to see it right here.
So,
All right. So the answer to your question, yes, we can. All right. We can pull this apart like this. But now you have to look at 2 separate problems.
is it better just to look at 1? It is what it is.
It is what it is, yeah. So let's talk about the domain of this one. X plus 1 must be
Greater than 0.
greater than 0. This one over here,
X minus 3 must be greater than 0.
so here x must be greater than 3, and here x must be greater than -1. Let's try this. -1's here, 3's here. Greater than 3 is this way. Greater than -1 is this way, right? Where do they overlap?
3 and greater.
From 3 and greater, right? From 3 and greater. Including 3 or no? Not including 3. So 3 to infinity? Like that? Everything to the right?
That
That seemed kind of simple, right?
Yeah,
Okay.
that's why I'm like, that's it.
Yeah, Yeah.
So would it be like negative 1?
That's it.
I
Huh?
was like, that's too simple. I mean,
Okay, so it's where they overlap. I should have maybe done it in a different color. To make this one true, right, x has to be bigger than 3.
So it's just where they overlap.
It's only where you have to satisfy both at the same time, right? So the other one is everything from here on forever.
it's kind of like simple.
And so it's wherever they overlap.
Why can't it be lower than those numbers?
With the exponential.
Let's see. Let's try it. Let's just try a number. Let's just try a number right here. How about negative 2? So,
You said that a log can't be a negative number, can it?
no. You can plug negatives into logs. You just can't have the argument turn out to be negative. So this is a good question right here. Negative 2. What do you get if you plug in negative 2 right here? Negative 1 over, what's negative 2 minus 3? Negative 5, what's negative 1 over negative? Negative? Positive? It's negative 1 over negative 5, which is 1/5. That's okay, isn't it?
Yeah.
So we have a major issue here,
Uh-oh.
which is why I told you, can we split this, right? Can we split this? And I said, yes, it doesn't remove, the problem of the 3 is not removed, right?
See, I knew this was too simple.
That's right. That's why I was like, that's straightforward, isn't it? That's straightforward if we split it
I
up.
was just constantly wondering that while you were doing it. Like,
Good.
Constantly writing greater than.
Because I knew, like, I was looking at it, like, that can't be it.
So when we have something like this, we can use the properties to split them up, but we might lose sight of some of the domain restriction. And namely because we know that this can't be negative, right? We know that this can't be negative. But if they're both negative at the same time, back here, negative over negative is positive. So what do I look at, that one or this one? How was the problem originally given to you?
You need to look at the whole picture. Like, so basically, the first next that came up with 3 to infinity is the correct one. Because at the end of the day, you can't have the bottom the be 0.
Yes, but negative 2 just worked. See, negative 2 right here works in this expression, right? Because you get 1/5 in there, don't you? Positive 1/5?
Right.
And you can plug a positive number into a log.
Maybe it's got a
Understand?
So would it be something like,
You have
just
both
guessing
along.
here, but like negative infinity to 0, union? 0.
It's going to be a union, but let's see. Let me try and kind of back up a little bit and make sure one point is clear. This is the way the original problem was stated, yes? We did some sort of property of logs to get it to here, right? In that, we actually created a dangerous area here.
So we should do that.
I wouldn't, all right? Just because you create that potential danger.
And we fell into it.
And we fell into it. So instead, all right, instead, see, I didn't want to turn you away from your instinct, but let's go back to how we do domains of logs. We look at the argument. What's the argument here? And we need that to be bigger than 0, right? This is called a rational inequality. That's a rational inequality. Do you remember how we did this?
Yeah, we just tried it.
If I asked you to sketch this function right there, that's a rational function. That's one of those ones where you find the x-intercepts, you find the vertical asymptotes,
Well, first,
horizontal asymptotes. Remember all that stuff?
well, the bottom one tells us the x-intercepts.
Top one.
Or the top one. And
Okay.
The other one tells us the horizontal asymptotes.
So what would the x-intercept of that rational function be? Negative 1. That would be an x-intercept. Would I want to include that or not?
No, it's.
I don't want that, but it's an important point in the problem, isn't it? I don't want to include it because I want it to be greater than 0. I also have another place where something interesting happens, and that's where?
At 3.
At 3, when I get division by 0. That's where we have vertical asymptote from graphing. Are you making the connection here? I'm trying to get you to see that the way we solved rational inequalities, all we did is we looked at the x-intercepts and the vertical asymptotes. So we set the top equal to 0, we set the bottom equal to 0. That's basically what we did. So we get 3 over here, right? Do I want that 3?
No.
Absolutely not. But this partitions our number line into 3 sections. And then what we do is we just check each section. We check here, here, and here.
So it's just like when we were graphing them.
Exactly. Well, we're not going to do the horizontal
Well,
part.
obviously,
Yeah.
Right.
So I checked -2, and we did that a second ago, didn't we? We got 1/5,
It worked.
and that is bigger than 0, so that worked. We could plug something in here like 0.
And that would be bigger. That would not be 0.
That'd be 1/3 over negative. That'd be 1 over -3, which is -1/3. Not going to work.
No, wait.
4.
Would -2 work? Because, I mean, it's positive on the top, but then it...
No, it was negative on the top.
Oh, yeah, negative on the top, negative on the bottom.
Yeah, it works.
Okay.
And plug in something over here. So 0 doesn't work. 5, sure. 5 works?
6 over 2.
Yeah, so it works. So your domain should always be taken off of the function the way it appears when it's given to you. If you do any sort of property or manipulation, there's always the potential that you're going to lose some of that domain in that. So the domain of this is negative infinity, -1, right? Union 3 to infinity. That's a little tricky, huh?
Did the base even matter?
What's that?
Did the base of the problem even matter?
No, base had made no impact at all.
Why is the log base 7?
I had to choose something. I was just trying to mix it up. I didn't want to keep writing natural log, natural log.
I just don't see the point of adding a log.
Log-based elephant.
Log-based elephant.
So what you're telling me is if that was log base 10, I would have the same answer.
Well, I mean, I'm questioning whether or not the base of the log even affects anything.
That's a great question. It doesn't affect your domain
Okay.
at all.
It does not affect the domain.
Mm-mm.
At all?
Nope.
Does it affect the range?
No.
So then it doesn't matter.
As far as the minimum,
Wait, range,
but if you're like actually.
range, it will because of what's inside of it. Like if you had that expression in there, that would affect it.
Okay.
Yeah.
But it's not going to affect the domain at all?
No. It's independent of the
Unless you're
base.
trying to get a number out of it.
All right, I think that that's probably sufficient for you to kind of mess with those domain problems on your own. All right, back to 6.6. We were solving equations last time, weren't we? Solving equations? We were. And so what I want to do is now crank it up just a little bit and give you some
Yeah, then you showed us
more
that you
complicated
weigh the
one.
natural log, and then you find out all that mumbo jumbo.
Yeah. You want to do one more of those before we? No, I didn't enough.
You did like 1, 2,
Like 4 or 5.
you did 2, 3. Is this another example?
Yeah, sorry, this is an example.
I was like,
Solve for x.
okay.
Maybe I should just remind you on the side here before we do this one.
Do we multiply the 2?
Yeah, let me remind you. Hold on, because I want you to see what we did last time. If we had something like this, 5 to the x minus 2 equals 3, like that, then what I showed you last class,
You bring down the natural log.
you can bring natural log in on both sides, right? So you could do something like natural log. And why do I use natural log and not some other log?
Because we have a button for it.
Because we have a key on the calculator for natural log, right? So I do that.
Because it's convenient.
That's right. And then I drop this down, don't I? I have to put that in parentheses. And then at this point, I could just divide natural log 5 on both sides. And then I don't need the parentheses anymore, do I? And then I could add 2 to both sides. So I get x equals natural log 3 over natural log 5 plus 2, whatever that is. And I can get my calculator out and do that if I wanted to. Yeah? The idea that I want you to remember is that we brought in the natural log on both sides so we could drop the powers down. Now let's take a look at this one. Any ideas? It's a very good question. Okay, so if I do natural log on both sides, it's not like multiplying, right? I told you all that last class. You're not multiplying by ln. You're taking ln, or you're plugging both sides into the natural log. So don't write this down, but this is what we would have to do if I was going to try and do it on both sides right now. This is what I would get.
And you're still in the same boat.
Can I do anything on that left side? Can I drop any powers down? No, because they're separated by addition. Can I split it into 2 logs? No, because to split it into 2, you need what? Multiply?
Multiply the 2x and the x.
Multiply these two? How?
Take a GCF.
Like make it 3 and then 2 times 2x squared.
3 times.
Might be wrong.
Oh, yeah. I think what you're doing is trying to put these together and multiplying these two together.
Yeah.
Can't do that. What you can do is this. Look, if you have x to the n times x to the m, so same base, different powers being multiplied, that's x to the n plus m. But you have to have multiplication, which we don't have. The only time you multiply the 2 powers is if you have this. That's when you multiply the powers together.
So do you just move one of those 3's over?
So you could, if you want, algebraically move one of those over. If you moved it over and then did the natural log, on the other side, wouldn't you still have like 2 things separated by addition or subtraction, though? Right? Like if I move this over, these would still be separated by, in this case, subtraction.
So if you divide
Divide?
one of those to the 2 or not?
Well, if you divide both sides by something, you have to divide everything by it, right?
I think he's saying like subtract, say the 3x, and then
The 3 to the x on both sides?
3x, and then turn the right side into division, like from subtraction.
Yeah, see, look, you have to be careful. Look, if you do, the reason why I'm showing you this is because I don't want you making these types of mistakes on the test. Right, so look, let's say you do that. I think that's what you meant, move it to the other side.
Yes.
Then if you do natural log, and then you do natural log here, you have to do the whole thing.
You're still in the same boat.
Same problem. You cannot turn that into division.
Oh,
Right.
They have to be separate in this.
2 logs being subtracted can be turned into 1 log with division in it,
But this is
but not the other way around. We're screwed. I don't know. Ask a tutor. No, I'm kidding.
Oh, yeah.
Yeah, you
That'd be a good answer, wouldn't it? I don't know. Go ask the tutor. I don't know.
totally just gave us the Kobayashi version. It cannot be done.
All right, this is a little tricky. That's why I kind of saved it for today. Just tell me if you agree with this.
We have a problem.
Do you agree with that?
Yeah, because you're just going backwards from the exponent one that you just showed.
Exactly. So I can rewrite that way.
That's the same base.
So no one disagrees? All right, we're going to use substitution. U is equal to, what do you think?
3x.
3 raised to the x, right? 3 to the x.
So u squared plus u equals 2.
So we get u squared, right? That's this. U squared plus u equals 2. What type of equation is that?
Quadratic.
Quadratic.
We got this.
We got it now. So we'll move everything to one side. And
You know, I'm gonna just sub all the way
Factor?
down.
factor.
and 1, but I'm not.
2 and 1.
So positive 2, negative 1.
Positive 2, negative 1.
So U is 1 and negative 2.
Any questions? What I did here?
And are we going to
Now
have to
we
test
need to
this
sum
one?
it back.
Are you what?
Are we going to have to test both?
We actually need to get back to the answer. We're trying to solve for x right now, right?
Yeah.
My answer right now is u. I need to get back to x. So,
Now you need to put yourself back in.
so let me write down what we have here. From this, you're telling me that u must be negative 2, and then you're also telling me that u must be 1.
Yes.
Now, what was u?
U was 3 to the x.
3 to the x. So this becomes 3 to the x must be negative 2. This is 3 to the x must be 1.
Now we can use the natural log.
Now you can natural log both sides. Now you can. Pardon? Okay, so you're 0? Is that what you're thinking? Good. All right, so here, now these equations can be done using natural log on both sides. So natural log, or you can just look at that one and tell probably what the answer is. Equals natural log of negative 2. Do you see right away on the left one, we have a problem? Can't plug negative 2 in to a natural log, to any log. So there's no solution over here for this side. Over here, you could just look and say, well, obviously 3 to the 0 is 1. But if you went through and did it, you would do natural log of 3 to the x equals natural log 1. You drop the x out. X times natural log 3 equals natural log 1. And natural log 1 over natural log 3. But when you get on your calculator and you take natural log of 1, you're going to get 0. Aren't you? Log of 1, any log of 1 is 0. And 0 over a number is 0. So we get 0. So the only solution we have is x is 0. So be prepared to have an exponential equation that is going to involve you solving a quadratic equation.
It's interesting how you do that.
I'm going to give you another one. Okay? I want you to try this one.
I have a feeling you're going to do something like this on a test.
Yes.
Gee, I wonder why you could have to-
He's like,
You will have one of these. This is a classic, algebra
yeah, he's gonna be
exponential
like,
equation
you're
problem.
gonna have to use x and z to solve for u to solve for the log.
But
No.
it's also going to be a 40. Just to spite us.
It's 2 to the 2x times 2 to the x.
All right, would you like to try that one on your own?
Sure, why not? It's not like you're electrical.
Very similar to the last problem, so I'll see how you do on that. Had anybody gotten there on their own? Yeah.
Yeah, wait, but I actually got the same answer.
You got the same answer?
I did a different method though.
Did you turn it into a quadratic?
I took the u's and I made like 2x, and then just left the 4 and the 2x by itself, so it was 2x, u squared plus 4 times u equals 12, so I just made it u cubed plus 4 equals 12.
You may have accidentally stumbled onto the doorstep here, but
I actually erased it because I've got it.
okay.
I'll show
Okay.
I'll redo it so I can show you.
Well, don't redo it that way because I don't think that way is going to work. I think you might have just got it by luck.
Hey, it's better to be lucky than good.
In some things, I think you're right.
I just don't want to be walking on his bridge.
Hey, sometimes they hold up.
All right. I think some of you have this one.
It's kind of bad.
Anyone have a question on it?
Okay, I went ahead and redid it. Like, redid what I did, so if you want to see it.
Yeah, I do. I'm going to give you another one to do. Mm-hmm.
U cubed plus 4 equals
Remember, if you build the boat,
Oh, whoa.
What do you
Yeah, no, you got lucky.
call the person that pilots the boat?
You got lucky.
first I changed it to
Yeah, because that.
and I'm like, and that was just messing me up.
How did you get u cubed?
I took this the u squared here and multiplied by this u here.
You can't. They're being added together.
Guess I just got lucky.
Yeah.
So anything is with a negative on the right?
Yeah. No solution. Yep. Yeah. If you ever, there's kind of a pattern here you can pick up on. If you ever see something like this, you know, this equals a negative number, there's no answer, no solution, because the first thing you do is take natural log on both sides, and you would get natural log of a negative number. So, all right, let's look at this one. See if you can solve this. A little more challenging. I don't know.
He's just gonna do it.
Which one do I want to give you? Mm-hmm. I think I'm going to let y'all mess with this one for a few minutes. Talk to each other if need be.
I think this was good. What if it's that same thing as the last one?
I'm going to see what you can do in like 3 minutes. I'm going to take a little quick step out real quick. Well, progress or no?
Not really. Well, I got some. I thought I had a good idea, and it didn't turn out to be such a good idea. Because I was thinking we could use u substitution and for e to the x, because then you have a negative exponent out there.
So you're thinking of u substitution of what?
E to the x.
Anyone else do that?
But then you have negative 1 out there, and I didn't know what to do with it.
Yeah, so that's where we're at.
Because if you do that, you won't end up with the quadratic.
What, the e to the negative x?
Well, because if e, usually something to the negative 1 power, you can move it to the denominator,
Mhm.
and then it makes it a positive power.
Yeah, so like x to the negative 2 is 1 over x squared, like
Yeah.
that.
So I did e to the x over e to the x, but then I just got
Like that's that. That's right. I mean, you can do this. What's that? Yeah, we have to deal with that, but I'm just saying this is a legitimate move to make e to the negative x 1 over e to the x. Letting u be e to the x is also a legitimate move. So, which do you prefer?
Which is better.
Yeah, let's just keep it e to the x.
Yeah, let's just keep it e to the x.
Okay, so if we could rewrite this way. Right? That's right. Common denominator, you can do that, yes. But because it's an equation, you could even go easier and just clear all fractions. You can multiply both sides by the common denominator. So if I multiply both sides by the common denominator, I'm multiplying both sides of the equation by what? E to the x. E to the x here, e to the x here. What happens when I multiply e to the x times e to the x? I get e to the x squared. E to the x times 1 over e to the x. E to the x over e to the x, which is 1, equals e to the x. Now you have a quadratic. Let u be e to the x, which would be u squared plus 1 equals 6u. Bring everything to one side. U squared minus 6u plus 1 equals 0. That all right? That's not going to factor. So you have to do what? Quadratic formula. You remember the quadratic formula, right? Negative b. So watch, I'm going to write u equals, not x, right? Because my variable is u. Negative b, so 6 plus or minus the square root of
4ac.
b squared.
No, b squared minus 4ac.
Negative 6.
Squared 36 minus 4 times a, which is 1, times c, which is 1, so just 4, over 2 times a, so just 2.
And what was like the actual formula in terms of variables? Like
It's negative b plus or minus square root b squared minus 4ac all over 2a.
I'd like to know how somebody came up with that.
You never seen it? I can show it to you all if you want. After this. Okay, so this is going to be u equals 6 plus or minus the square root of 32 over 2.
So that's, you can take out 4 out of that.
That'd be 3 plus 1.
Yeah, so you can take out, what's 6? What, 4 times,
It's 4 times 8.
4 times 8, so how about 16 times 2?
Yeah.
So 4,
16,
that's what I meant, like,
okay, you can take a 4 out, okay, I misunderstood you. Square root
and
2 over 2. And you can reduce the 6, 4, and 2 by 2, right? A factor of 2. So you get u equals 3 plus or minus, 2. Root 2. We have 2 answers, right? Those are them. Any questions? Okay.
That's not going to be 3.
U is equal to 3 plus 2 root 2. U is equal to 3 minus 2 root 2, right? What's U? E to the x.
No, you, like whenever you're saying us,
Mhm.
very confused.
That's this and this. I'm curious if this is a negative number or not over here. Root 2 is 1.414, something like that, times 2, times negative 2, and then I believe it's positive or negative when you do 3 minus this. It should be a positive. This should still be a positive number. Yeah. So it's positive. This is positive. So we actually are going to have two different answers here. To get what x is, we need to come in on both sides with natural log, right? That's what I'm going to do to drop the x out the front. So I'm going to go natural log of e to the x equals natural log of 3 plus 2 root 2. And then over here, natural log of e to the x equals natural log of 3 minus 2 root 2. And something nice happens on the left side. Yeah, this is natural log and e, natural log of e to the x. Those cancel each other out. So this just gives me x on the left.